Hello everyone, this is Kushi presenting in my project LipSync.ai, a lip reading model. The focus of this project is in developing a system for lip reading. Our goal is to analyze spoken words by analyzing the movement of a person's lip in the videos. To achieve this, we will be using the power of convolutional neural network or CNN for short. These are the deep learning models that excel at extracting key visual features from the images. In our case, the CNN will analyze each frame of the video, focusing on the mouth region. Once the CNN identified these key features like lip shape, position, and the movement of the lips, a bidirectional LSTM will come into the play. LSTM is another type of deep learning model that's particularly good at analyzing the sequence of the words. It will be analyzing the sequence of features extracted by the CNN across multiple video frames, essentially capturing the flow of lip movements during the speech. By combining the strength of CNN and feature extraction and LSTM and sequence understanding, we aim to achieve accurate lip reading. This technology has the potential to unlock new possibilities for silent communication, particularly for people with hearing loss, and could also be beneficial in noisy environments where noise gets muffled. The models use the CNN and bidirectional LSTM. CNN will be identifying key features like the shape, position, and movement of the lips in each frame. Bidirectional LSTM will learn the temporal patterns considering how lip change changes from frame to frame to understand the sequences in the sentence. This is the model architecture of our project. So, firstly, we will be transforming the lip video into several frame images. We use several frame images as the input. Each frame passes through the already trained CNN architecture, and then the output of CNN is passed to the dense layer for transforming to the LSTM layer input. The output of the LSTM layer became the next dense layer input, finally receiving the output layer by a softmax activation function. Our trained region is a dense layer function of CNN architecture. So the use cases of this project are first, the assistive technology for hearing impaired. Lip reading projects can be used to develop tools that help people with hearing loss understanding conversations better. Second one is security and surveillance. In certain security settings, lip reading technology might be used to analyze silent conversations captured on the video. This could be helpful for understanding situations where people are trying to be discreet. And the last one is speech recognition in noisy environment. In situations with loud background noise environments where microphones struggle to pick up the clear audio, lip radio technology can be come into the rescue. By analyzing lip movements, the system can potentially understand what's being said even when the sound is muffled. Thank you. Now, moving on to the code part, we have main three files, util.py, modelutil.py, and streamlit.app.py. So the first file is utils.py. In this file, firstly, we are doing vocabulary setup. The vocab variable contains a list of characters that the model will recognize, including the lowercase letters, digits, some special characters, and the space. Two string lookup layers are created to map characters to integers and the vice versa. Then we are having load video function. This function takes a path to a video file and then loads a video frame. It iterates through each frame of the video, converting it to the grayscale and extract a region of interest from each frame. The ROI is then standardized using mean and standard deviation normalization and returned as a list of tensors. Then we have load alignment function. This function load aligns data from a file typically containing information about the timing and content of the spoken words. It filters out silence tokens and converts remitting tokens into the integers using char to num function. Then we have load data function. This function integrates the previous two functions to load both video and the alignments given a file path. It extracts the file name from the path, constructs path to the video file and the alignment file, and then calls load video and load alignment functions to load the data. Second one is modelutils.py, in which we have used the combination of convolutional neural network and bidirectional LSTM. So first is convolutional network layers. These layers apply 3D convolution to capture special features and temporal features in your input data. Each convo 3D is followed by ReLU activation function to introduce non-linearity and then a maximum 3D layer for downsampling. Then we have our time distribution flatten layer. This layer flattens the output from the convolutional 3D network while preserving the temporal dimensionality. It's necessary to feed the output in a recurrent layer like LSTM. Then we have our two layers of bidirectional LSTM. These layers consist of two LSTM, one processing the input sequence from beginning to the end and another processing it in the reverse. This allows the network to capture dependencies in both the directions. Dropout layers are added after each LSTM to prevent overfitting. And then in the last, we have our last layer, dense layer. Finally, a dense layer with softened activation function is used to produce output probabilities for each class. And then we have our file, which is used to provide the user interface to our system. In this, first we are setting up the sidebar. The sidebar includes an image and the title for the application. Then there is the code for selecting a video. Users can select a video file from a drop-down menu populated with video files found in the specified directory. Then the selected video is rendered in one column using the streamlets st.video function and this column. Then in the column 2. In the other column, the selected video is processed by the machine learning model. The video frames are loaded using the load data function from the utils module. The processed frames are then saved as a GIF animation and displayed using the image. The model's predictions are obtained using the load model function from the model.util.py file, and the row token predictions are converted into text predictions and are displayed using st.text. So this is the UI of our application. First, here is an option to choose any video. Suppose I choose this video. Then here in this column, it will be showing the original video which you have chosen. Now in this section, you are seeing the animation which is created by just converting the video into the frames and then converting those frames into the videos. And in the mid, we have applied grayscale encoding. Then here the tokens are displayed after the prediction what we have received as tokens. So there I have displayed the tokens. And then after that, we are using UTF-8 encoding and the tokens are converted into the words. So here it speaks, or you can say it lips like been blue at L6 now. So it will be predicting it as been blue at L6 now. Also, whenever 39 is encountered, it means that a word is completed and it is taken as a space. So it reads the model. Yeah, this is about my project, and this is my UI.